You are welcome to my channel. In this video, we discuss about atoms, ions, and molecules. Atoms, ions, and molecules. So in today's class, we are going to learn about structure of an atom. You learn about particles of an atom. We learn about ions. What are ions? Then we talk about the types of ions. Then we discuss about the atomic number and the mass number, which will lead us to the calculation on the number of protons, neutrons, and electrons. Then finally we discuss about molecules. What are molecules? Then we talk about types of molecules. So let's begin with an atom. An atom is derived from the Greek word atomos. An atom is derived from the Greek word atomos, which means indivisible. Atomos means indivisible. Indivisible is a thing something that cannot be what? Something that cannot be further divided or splitted into smaller particles. So it shows that an atom cannot be further divided or splitted into what? Into smaller particles. An atom is so tiny, it is so tiny to the extent that it cannot be what? It cannot be seen with naked eye. It cannot be seen with naked eye. Then you cannot observe an atom by an ordinary microscope. Then you can only observe an atom by a specialized microscope such as electron microscope or scanning tunnel microscope. Now let's look at definition of an atom. An atom is the smallest particle of an element which takes part in a chemical reaction. The smallest particle of an element which takes part in a chemical reaction. So what is the meaning of that first statement? Atom is the smallest particle of an element. That is, an atom is an element when it's involved in what? In a chemical reaction. An atom is an element when it comes to what? A chemical reaction. Now, let's take for example, Na is the chemical symbol for sodium. Sodium is an element when it is standing on its own. Sodium is an element when it is standing on its own. But when it reacts or combines with another element to become a compound, let's take for example chlorine. When it reacts with chlorine to form a compound, you don't call it what? An element anymore. You call this what? An atom. So when it comes to what? A chemical reaction, an element becomes an atom when it comes to a chemical reaction. Then three scientists J.J. Thomson, Ernest Rutherford, and James Chadwick discovered another particles inside an atom. They discover particles inside an atom called subatomic particles. They call them what? Subatomic particles. So what are the subatomic particles? Subatomic particles. So they are the protons, neutrons, and electrons. Protons, neutrons, and electrons. Proton was discovered by a scientist called Ernest Rutherford. Then neutron was discovered by a scientist called James Chadwick. Then electron was discovered by a scientist called J.J. Thomson. So these are the three what? These are the three subatomic particles. Then which leads to what we call the structure of an atom. Then the proton is positively charged. Neutron is neutral. So it shows that neutron has no charge. Then electron is negatively charged. Then the mass of proton is 1, which is equivalent to the mass of neutron. So the mass of proton and the mass of neutron equal to 1, while the mass of electron is about 1 over 1840. 840. So these subatomic particles leads to what we call the structure of an atom. It leads to the structure of an atom. Then we represent the structure of an atom by a circle. Then in mathematics we call it what? This is a circle. We call it what? A circle. But in chemistry we call it what? Electron shell. We call it electron shell. So it is not a circle in chemistry. We call it what? An electron shell. We call it electron shell. While we call the center, we call this one center of a circle. But in chemistry, we call it what? Nucleus. We call it nucleus. So we call it what? Nucleus. So the center of a circle is called nucleus of an atom. Nucleus of an atom. So why we call the circle what? Electron shell. We call it electronic shell. Electronic shell. Or we call it what? Electron shell. Now, on this electron shell, we have electron. That's why we call it electron shell. Because electron revolve. It revolves around the shell. That is, it moves around. It travels around the what? The electronic shell. So this dot, we represent dot by what? By electron. So this is electron. This is electron. Then inside the nucleus of an atom, we have what? We have proton and neutron. We have proton and neutron. We have protons. We have protons and neutron. Neutrons. So we have protons and neutrons inside the nucleus of an atom. Then the proton is what? Is positively charged. Proton is positively charged, while electron is what? Is neutral. Electron is neutral. That is, it has no charge. So we have positive charge and what? And neutral. Positive charge and neutral. So proton is what? Is positive. It carries positive charge. It carries positive charge. While neutron is what? Is neutral. That is, it has no charge. Now the proton and neutron which are present in the nucleus of an atom are called nucleon. Nucleon are the proton and neutron present in the nucleus of an atom, because they may ask you to define nucleon. Nucleon means nucleus of an atom. Then what are those things that are present in the nucleus of an atom? They are the protons, what? And neutrons. So protons and neutrons are the nucleon. Now the electron revolves around the what? It revolves around the shell, or it travels, or you say it moves around the shell. Now with this, now you can explain what we call the structure of an atom. The structure of an atom. So you start with the structure of an atom consists of the proton, neutron, and electrons. Then the electrons revolves around the what? The shell. While the proton and neutron present in the nucleus of an atom. The proton is positively charged. The neutron is what? Is neutral. While the electron is what? Is negatively charged. Then the proton and the neutron present in the nucleus of an atom are called what? Are called neutrons. So with that, we have explained the structure of an atom. Then the particles of an atom are the proton, neutron, and what? And electron. Now let's move to ions. So let's talk about an ion. Let's talk about ions. What is an ion? An ion is an atom or group of atoms with electrical charge. An ion is an atom or group of atoms with electrical charge. With electrical charge. That is, an atom, an ion is an atom or group of atoms with electrical charge. That is carrying positive and negative charge. Carrying positive or negative charge. So an atom becomes an ion when it loses or gains electrons to become positively or negatively charged. So an atom becomes an ion. An atom becomes an ion when it loses or gains electrons to become positively or negatively charged. So when an atom loses an electron or electrons and become positively charged, we call this what? Cations. So what are cations? Cations are positive ions. Cations are positive. They are positive ions. They are positive ions. So an atom become a cation when it loses electrons. An atom becomes a cation when it loses electrons. Then it becomes an anion. It becomes an anion when it gains what? When it gains electrons. So it will gain electrons and become negatively charged. An atom gains electrons and become negatively charged. So called what? Anions. So anions are what? Are negatively charged. So are negative ions. So anions are what? Are negative ions. So when an atom carries what? A positive charge. When an atom carries a positive charge, you call it what? A cation. It is a cation. So you call this what? A positive ion. When an ion carries what? Positive charge, you call this what? A cation, which is called what? Positive ion. Then when an ion's what? When it carries what? A negative charge. When it carries a negative charge, you call this what? An anion. An anion, which is what? A negative ions. Which is a negative ions. Then how can we determine cations? Now let's write examples of anions. Examples of anions. Let's talk about cations. So examples of cations are sodium ion. So when sodium is standing on its own, you call this what? An element. So when it comes to a chemical reaction, you call this what? An atom. Then when it now carries what? A positive charge, you don't call it what? You don't call it an atom, you don't call it an element. So you call this what? An ion. So this is an ion. So you call it sodium ion. Then how can we determine the charge? How can we determine or how can we find this charge on what? On sodium or on positive ion? Now, sodium is in number 11. Now, if we write the electronic configuration of sodium in ratio form, that would be 2:8:1 according to our electron distribution. The first shell we carry what? We carry maximum of 2 electrons, while other shells carry what? Maximum of 8 electrons. Then you don't what? Move to another shell if you don't complete one shell. The first shell we carry what? Maximum of 2, while others carries the what? 8 electrons. Now, out of 11 electrons, the first shell carries what? 2, then the second carries what? 8, then the third one carries 1. So 2 plus 8 plus 1 will give us 11. So the valence electron for sodium is what? Is 1. Therefore, the charge on sodium is 1. So we determined what? The number of charge on cations by their number of valence electron. The number of valence electron will determine the charge that what? That a positive ions will carry. Then the positive ions are those one with what? With 1, 2, and 3 valence electrons. So positive ions are those what? Elements or atom with 1, 2, and 3 electrons on their outermost shell. So elements with 1, 2, and 3 electrons on their outermost shell, they are called what? Positive ions. So they are the positive ions and they are called what? Cations. So this one is having 1 valence electron and therefore the charge on it is +1. Now let's look at another element, magnesium. Magnesium is in number 12. So to write the electronic configuration of magnesium, that will be 2:8:2. It has 2 valence electrons. It has 2 valence electrons. So therefore the charge on magnesium will be 2+. So magnesium will now be what? It will become what? An ion. It becomes an ion. So we call it magnesium ion. So we don't call it what? An atom anymore. We call it magnesium ion. So another element, another atom or ion is aluminium. So let's look at aluminium, Al. Aluminium is in number 13. So the electronic configuration will be 2:8:3. 2:8:3. It has what? 3 valence electron. It has 3 valence electrons. So therefore the charge on aluminium will be 3+. So don't forget that those elements with 1, 2, and 3 valence electrons are positively charged. They are positively charged. So the charge on aluminium will now be what? 3+. So it will become what? Aluminium ion. Aluminium ion. You call this what? Aluminium ion. So let's proceed to anion. Let's proceed to anion. Then anions are what? Are negative ions. Anions are negative ions. Then they become negative ions by what? By gaining of electrons. They become negative ions by gaining of electrons. That is, they need more electrons to complete their outermost shell. They need more electrons to complete their outermost shell. Now, those elements with 5, 6, and 7 valence electrons are negatively charged. Those elements with 5, 6, and 7 valence electrons are what? Are negatively charged. So anions are what? Are negative. They are negative ions. So they are negative ions. Now let's take oxygen for example. So what will be the charge on oxygen? Oxygen is in number 8. Then according to our electron distribution, the first shell will carry 2 out of 8, then remaining 6. Now this valence electron supposed to be 8, then it needs 2 more to balance that 8. It needs 2 to balance that 8 electrons. So therefore the charge on oxygen will now be what? It will be 2-. So oxygen ion will now be 2-. To write oxygen ion, you call it what? O2-. Now let's take another example. Before oxygen we have nitrogen. Then nitrogen is in number 7. Then the first shell we carry 2, then the second shell we carry 5. 2 plus 5 will give us 7. So the valence electron is what? Is 5. So it needs 3 to complete that 8. So nitrogen ion will now be what? N3-. Because it needs 3 to complete the what? The outermost shell electron. So let's take another element. Let's look at sulfur. Let's take chlorine first. Chlorine is in number 17. So the electronic configuration will be 2:8:7. 2 plus 8 plus 7 will give us 17. So The last what? The last valence electron is what? Is 7. That is, it needs one more to balance this, the 8 electrons that's supposed to be here. It needs one more. So therefore, the charge on chlorine will be what? Will be minus, -1. So which is the same thing as minus. So we don't always write it as -1. So it's minus. So -1 means minus. It means minus. Then sulfur. Sulfur is in number 16. So the electronic configuration will be 286. 286. That is 2 plus 8 plus 6 will give us 16. So the last word shell means what? It needs 2 more to balance that what? That 8 electrons. So therefore the charge on sulfur will be 2. So we call it S2 minus. So sulfur ion will be what? S2 minus. So that is how to determine the number of charge on what? On anions. On anions, which are the what? Negative ions. Which are the negative ions. Now let's move to atomic number and mass number. Atomic number and mass number. So let's talk about atomic number and mass number. Atomic number and mass number, which will lead us to calculation of the number of protons, neutrons, and electrons. Protons, neutrons, and electrons. Now let's first talk about atomic number. Atomic number. What is atomic number? What is atomic number? I'm going to define atomic number from the structure of an atom. I will define atomic number from the structure of an atom. Don't forget that I explained under atom, that is atomic structure, that the nucleus of an atom, which is called the center of an atom, consists of protons and neutrons. That is, this is the nucleus of an atom. Then inside the nucleus of an atom, we have protons, and neutrons. We have protons and neutrons. So the protons and neutrons are present in the nucleus of an atom. So what is atomic number now? Atomic number is the same thing as the number of proton. Is the same thing as the number of proton, which presents where? Inside the nucleus of an atom. So therefore, atomic number is the number of proton. Is the number of proton present in the nucleus of an atom. Present in the nucleus of an atom. So atomic number is the number of proton present in the nucleus of an atom. Now, let's take an element, for example, carbon. Carbon is the number 6. When you count your first 20 elements, carbon is the number 6. So the atomic number of carbon is 6. The atomic number of carbon is 6. So if the atomic number of carbon is equal to 6, so it shows that the number of proton will also be equal to 6. Why? Because according to this definition, the atomic number is the same thing as the number of proton. Is the same thing as the number of proton. So if atomic number of carbon is 6, the number of proton will be equal to 6. The number of proton equal to 6. Then let's look at another element. Let's take silicon. Silicon, when you read your first 20 elements, silicon is a number 14, which shows that the atomic number of silicon is 14. The atomic number of silicon is 14. So therefore, the number of proton for silicon will be equal to 14 because atomic number is equal to the number of proton. Atomic number is equal to the number of proton. So let's define mass number. What is mass number? Mass number is the sum of proton, and neutrons. Is the sum of protons and neutrons. Then the protons and neutrons are where? They are inside the nucleus of an atom. So mass number is the sum of proton and neutrons present in the nucleus of an atom. So mass number is the addition of proton and neutrons present in the nucleus of an atom. Now let's bring out the three particles of what? The three particles of an atom out. Then what are the three particles of atom? That is the subatomic particles. They are the proton, then neutron. So P stands for proton, N stands for neutron, while E stands for electron. So this is proton, this is neutron, this is electron. Now let's come back to this place. What is atomic number? Atomic number equal to the number of proton. Then what is mass number? Mass number equal to the sum of proton and neutron. P stands for proton, the addition of proton and what? And neutron. Now from these two definitions, we can look for the number of proton, we can look for the number of neutron. Then we need the number of electron. How can we calculate the number of electron? Electron equal to the number of proton minus the number of charge. So to calculate the number of electron now, proton minus the number of charge. Then your proton is the same thing as atomic number. So let's take different examples. Let's look at element X. So we don't know element X with mass number of 27 and atomic number of 13. Element X with mass number of 27. The number of is always the mass number. While the number down is the atomic number. So the number written up is the what? Is the mass number, while the number down is the atomic number. Now, the atomic number of that element X, we don't know that element now. The atomic number of the element X is what? Is 13. Then we determine an element by its atomic number. Then if they ask you that element X is what? Which element is X? So the element in number 13 in the periodic table is element X. That is aluminium. When you count your first 20 elements, hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminium. So aluminium is in number 13. So which means that element X is what? Is aluminium. That is not where we are going. We want to calculate the number of proton for element X, the number of proton, neutron, and electron. So what will be the number of proton? Then atomic number is the same thing as the number of proton. Then the atomic number of element X is 13. So therefore the number of proton will be equal to 13. Then how can we calculate the number of neutron? So let's come to this place because neutron can be found in this formula. Neutron can be found here. So let's bring out neutron out. Which is N. Let's make N the subject of the formula. Bring P down to this place. It will be equal to mass number minus proton. Now to find the number of neutron now, neutron will be our mass number. Then the mass number of element X is what? Is 27 minus the number of proton equal to 13. So 27 minus 13 will give us 14. So which means that the number of what? The number of neutron equal to 14. Now, to calculate the number of electron, electron equal to proton minus the number of charge. What is the number of proton? That is 13. Then minus, is there charge on this what? On this element X? No, it has no charge. So it is neutral, that is, it is equal to 0. So 13 minus 0 will give us 13. So the number of electron equal to 13. So that is how to calculate the number of proton, neutron, and electron. Now, if this element X becomes an ion, now how can we change element X to an ion? How can we change element X to an ion? Write the electronic configuration of X. X is in number 13, the first shell. X is in number 13. So the first shell we carry 2. Then the second we carry 8. Then the third we carry 3. Don't forget that I explained that those elements with 1, 2, 3 valence electron are positively charged. Now, the valence electron for X is what? Is 3. So therefore, the charge on element X will be 3 plus. So I've changed element X to an ion. Here it is an atom or an element. This is an element here, but here it is now an ion because it carries what? Positive charge. So the mass number still remain as what? 27. The mass number still remain as 27. Now let's calculate the number of proton, neutron, and electron for ion X. This is an ion for ion X. So what will be the number of proton, the number of neutron, and the number of electron? Don't forget that the number of proton equal to atomic number. Then the number of neutron equal to mass number minus proton. Then the number of electron is equal to proton minus charge. Proton minus the number of charge. Now let's come back to this place. The proton is the same thing as atomic number. Then the number down is atomic number. So therefore, proton equal to 13 because our proton is the number of proton equal to the atomic number. So proton equal to 13. Then what will be the number of neutron? Neutron is mass number minus proton. Then our mass number is 27. That is 27 minus the proton is 13 minus proton, which is equal to 14. So the number of neutron equal to 14. Then to calculate the number of electron is proton, which is 13. Electron is number of proton minus the number of charge. Then what is the charge on ion X? That is 3 plus. So plus 3, which is equal to 13 minus 10 plus will give us minus 3, which is equal to 10. So the number of electron for ion X equal to what? Equal to 10. So that is how to calculate the number of proton, neutron, electron for an atom and for an ion. For an atom or for an ion. So let's take another atom. Let's take another example. Now let's take another example. Let's use chlorine. Chlorine. So this is a known what atom. Then the atomic number of chlorine is 17, while the mass number of this element is 35. So this is an atom. This is an atom. Now you want to look for the number of proton, neutron, and electron. The number of proton, neutron, and electron. Then don't forget that your atomic number is the same thing as the number of proton. Then the number down is your atomic number. So then the number of proton equal to our atomic number. So therefore the atomic number equal to the number of proton equal to 17. Now to calculate the number of neutron, so according to this formula, neutron is equal to mass number minus proton. Mass number minus proton. So the number of this number up is the mass number, so which is equal to 35. Now 35 minus proton is what? Equal to 17. We give us what? 35 minus 17 will give us 18. So the number of neutron equal to 18. Now let's look for the number of electron. The number of electron. Electron is equal to proton minus charge. So the number of proton is what? Is 17. Then minus, what is the charge on chlorine? It has no charge. It has no charge. It is neutral. So therefore, the number of charge equal to 0. So 17 minus 0 will give us 17. Will give us 17. So that is the number of proton, neutron, and electron for chlorine atom or element. Now, if this chlorine, if it becomes an ion, if this chlorine, it is now an ion, so how can we calculate the charge, the number of charge on this chlorine? What will be the number of charge? Chlorine is a number 17. The electronic configuration will be 2, 8, 7. So the last shell needs one more to balance. It needs one more electron. So therefore, the charge on chlorine will be minus, which is the same thing as minus 1. Minus 1. Now, this is chlorine ion. This is chlorine ion now. This is an ion. So the mass number remains as 35. Then the atomic number remains as what? As 17. As 17. So let's calculate the number of proton, neutron, and electron for ion, chlorine ion, for chlorine ion. Now, what is the number of proton? The number of proton equal to the atomic number, so which is equal to 17. The number of neutron equal to mass number, which is 35, minus the number of proton, which is 17, equal to 18. Then to get the number of electron, electron is proton. The number of proton, which is 17, minus the number of charge, minus the charge. What's the charge on chlorine? That's minus. Minus is the same thing as minus 1. Minus 1. Then open the bracket. That is 17. Minus times plus will give us, minus times minus will give us plus 1, which is equal to 18. So the number of electron equal to 18. The number of electron equal to 18. So that is how to calculate the number of proton, neutron, and electron for an atom and for an ion. The number of proton for neutron, electron, atomic number is the same thing as the number of proton. The mass number is the sum of proton and neutron. The number of electron is the number of proton minus the number of charge. Finally, let's talk about molecules. What are molecules? Molecules are a group of 2 or more non-metallic atoms linked together by sharing of electrons. Molecules are a group of 2 or more non-metallic atoms. Molecules are a group of 2 or more non-metallic atoms linked together, linked together by sharing of electrons, by sharing of electrons. So it shows that molecule has to do with combination of two or more non-metallic atoms. Combination of two or more non-metallic atoms. So when two or more non-metallic atoms are combined together or are linked together by covalent bond, we call this what? A molecule. So we call that compound form a what? A molecule. So let's take for example, chlorine is an atom. Chlorine is an atom. So when you put two at the base, that is, you have two atoms of what? Two atoms of chlorine. Then two atoms of chlorine are covalently, that is, one chlorine plus another chlorine are covalently bonded together to give us what? Cl2. So therefore, we have two atoms of chlorine. So two atoms of chlorine join together to give us Cl2. So Cl2 is called what? Is a molecule. So you call it chlorine molecule. This is a molecule because we have two atoms of chlorine. Two atoms of chlorine. Now, another one, let's take hydrogen. Hydrogen is a non-metal. Don't forget, combination of two or more non-metallic atoms. So hydrogen is a non-metal. So when hydrogen is standing on its own, you call it what? An atom or an element. But when we have what? H2 at the base, it shows that this H2 is combination of two hydrogen atoms. So two hydrogen atoms with what? We combine together to give us H2. So H2 is what? Is a molecule. So you call it hydrogen molecule. Hydrogen molecule. So let's take atom of different elements. Let's take atoms of different elements. Carbon plus oxygen. Carbon plus oxygen can either give us what? Carbon 2 oxide, CO. CO is carbon 2 oxide. This is a non-metal, this is a non-metal. So combination of two non-metal will give us what? A molecule. So this CO2, that is carbon 2 oxide, is a molecule. It is a molecule. Now let's take another one. CO2, carbon 4 oxide, is also what? Is a molecule. So this is group of what? Three atoms. One atom of carbon and two atoms of what? Of oxygen, making three atoms. So when we have two or more atoms of non-metal, we call this what? A molecule. When two or more atoms of what? Of non-metals are covalently bonded together, we call this what? A molecule. Then nitrogen and hydrogen, which is called ammonia. This is ammonia. Then nitrogen is a non-metal. Hydrogen is what? Is a non-metal. So we have four atoms. One atom of nitrogen and three atoms of hydrogen. So this is a what? This is a molecule. This is ammonia molecule. Ammonia molecule. Now, we have two types of molecule. Then before we discuss about the two types of molecule, let's look at this. Is the reaction between sodium and chlorine a molecule? This is sodium chloride. This is the combination of two atoms, but sodium is what? Is a metal. Sodium is a metal, then chlorine is a non-metal. So traditionally, sodium chloride is not a molecule. Sodium chloride is not a molecule because it contains what? A metallic atom, which is sodium, and what? And a non-metallic atom, which is what? Which is chlorine. So reaction between a metallic atom and a non-metallic atom will not give you what? Will not give you a molecule. It will give you an ionic compound. It will give you. And so sodium chloride traditionally is not what? It's not a molecule. Let's look at another one. Calcium and oxygen. Calcium is a metal. Calcium is a metal. Oxygen is what? Is a non-metal. So the combination of metal and a non-metal will not give you a molecule. So you can't call it calcium oxide molecule. No, it is not calcium oxide molecule. So it is a compound. You can call it calcium oxide. Calcium oxide. So reaction between a metallic atom and a non-metallic atom will not give you molecule. So reaction between two or more non-metallic atom will give you what we call what? Molecule. Now, let's discuss about the two types of molecules. Number one, we have diatomic molecules. Diatomic molecules. Di means two. That is two atoms of non-metallic atom. Two non-metallic atoms. When we say diatomic, that is two non-metallic atoms. We give you what we call diatomic molecule. So it can be atom of the same element. It can be atom of different elements. So when you have two atoms of either what? Of the same element or different elements, usually non-metal, we give you what we call what? Diatomic molecule. Now oxygen is a diatomic molecule. Why? Because we have two atoms of oxygen. Oxygen plus oxygen will give you what? Oxygen molecule. So which is a diatomic, because we have two atoms of oxygen. Then when we have two atoms of the same element, we call it homonuclear diatomic molecule. So oxygen what? Molecule is what? Is a homonuclear diatomic molecule, because it involves what? Atoms of the same element. Another example of homonuclear diatomic molecule is chlorine molecule, because we have two atoms of chlorine to give us Cl2. Another one is hydrogen molecule. So atoms of the same element to give you what? Hydrogen molecule. So all these are what? Are homonuclear diatomic molecule, because it involves what? Two atoms of the same element. But when we have atoms of different elements like carbon 2 oxide, so carbon and oxygen, that is atoms of what? Two different elements, we call it heteronuclear diatomic molecules. So heteronuclear diatomic molecule. So carbon monoxide or carbon 2 oxide is under heteronuclear diatomic molecule, because it contains what? Two atoms of different elements. So number two type of molecule is polyatomic molecule. Polyatomic molecules. Polyatomic molecules. So what are polyatomic molecules? Atoms of three or more non-metallic atoms. A compound of three or more non-metallic atoms. So when it contains three or more non-metallic atoms, you call it what? Polyatomic molecules. For example, carbon 4 oxide. Carbon 4 oxide is what? Is a polyatomic molecule, because it contains carbon and 2 oxygen. 1, 2, 3. So we have three atoms. 2 oxygen and 1 carbon. So 3 or more non-metallic atoms linked together will give us what? Polyatomic molecules. When 3 or more non-metallic atoms linked together to form a compound, we call it what? A polyatomic molecule. Another example is ammonia. We have nitrogen and what? And 3 hydrogen atoms. 1 nitrogen, then 3 hydrogen atoms. We have more than 3 what? 3 atoms. So 3 or more non-metallic atoms will give you what? Polyatomic molecules. Then you call this one what? Ammonia molecule. This is carbon 4 oxide molecule. Then another one is H2O. H2O is a molecule, that is water. You call it water molecule, because it contains what? 2 atoms of hydrogen, that's 2 plus 1, making 3 atoms. So 3 or more atoms of what? Of non-metal linked together is called what? Polyatomic atomic molecules, polyatomic. Today's class, we've come to the end of today's class. With what we have learned today, go and lay your hand on any chemistry, JAMB or WAEC question, so you should be able to solve any question on atoms, ions, and molecules with what we have learned today. Now, if you are new here, kindly subscribe to Royal Learning Channel. Share this video with your friends. Bye. Keep on watching.